Okay, and this should be our last video on complex numbers. So we're going to look again at Moivre's theorem, but this time we're going to be looking at it to prove a trigonometric identity, which is just a fancy word for proving something like this. Okay, so they can ask a few different types of questions. They normally ask the one about sine 3 theta or cos 3 theta, which are pretty similar, but if they ask anything else, as long as you follow these kind of steps, you should be able to manage it. Now, even it can be quite difficult sometimes, so if you can't get it, that happens, but if you follow the steps, then you will get most of the marks anyway. Okay, so just follow these steps and hopefully you'll do fine in the exam. So we see that it's sine 3 theta we're going to prove. So the first step we're going to do is we're going to write out cos theta plus I sine theta to the power of 3. So this is a complex number in the polar form, just with length 1, so r is equal to 1, so we're just going to leave it out, and we put it to the power of 3. So the boring thing is now we just have to work this out, which is going to take a while, but we just have to do it. Okay, cos theta plus I sine theta multiplied by cos theta plus I sine theta, and then again cos theta plus I sine theta. So I'm just going to look at these two first. I'm going to leave this one till another few lines. So we're going to get cos squared theta plus I'm going to go I sine theta cos theta, and so that's cos theta by cos theta is going to be cos squared theta. Cos theta by I sine theta is going to be I sine theta cos theta. Now I sine theta by this, we're going to get another I sine theta cos theta, and then I sine theta by I sine theta. We're going to get, so I by I is going to be I squared, so it's actually going to be minus sine squared theta. Okay, and then multiply that whole thing by this here. I'm not going to write that again, but just so you know that is cos theta plus I sine theta in this bracket here. So I'm going to simplify this one bit first. So that's going to be equal to cos squared theta plus 2I sine theta cos theta minus sine squared theta, all multiplied by cos theta plus I sine theta. Okay, so we'll continue on. So now we're going to multiply cos theta and I sine theta by each term in this. So cos theta by cos squared theta is going to be cos cubed theta plus 2I sine theta cos squared theta and minus sine squared theta cos theta, plus, so I'm going to drop a line just because there's not enough space. So now it's I sine theta by each case here is going to be cos squared theta I sine theta, okay, minus 2. So the reason it's minus 2 is going to be I sine theta by 2I sine theta cos theta. So now this is really confusing. Follow the mouse and hopefully hopefully it won't be as confusing. I sine theta by 2I sine theta cos theta. So I by I is going to give us minus 1, and so 2 is going to stay the same, and then we're going to have sine squared theta cos theta, and now it's just the last one is going to be minus I sine cubed theta. Okay, so that should be all. Okay, yeah, so if we look at some of these, they're actually the same. So this one here, 2I sine theta cos squared theta is the same as cos squared theta I sine theta, so they're just rearranged, the cos squared theta and the sine theta. This is 2 and this is just 1. So first I'm going to write this is going to be on its own. It's going to be cos cubed theta, and this is going to be all together is going to make plus 3I sine theta cos squared theta, and this is going to be the same except it's going to be minus 3 sine squared theta cos theta and minus I sine cubed theta. Okay, so this is this all multiplied out. Okay, and now we see why de Moivre's theorem is so helpful, that we don't have to do this, but just for this particular question, when we're proving this, we do actually have to multiply it all out. Okay, so now this is what we have. We're going to put the I bits together, so the real bits together, and the imaginary bits together. So this is imaginary because there's still an I in it, and this is imaginary because there's an I in it. I know it's difficult to see the I's when you have sine as well, but this is still the I bit. Okay, so we're just going to break that up, and I'm going to write cos cubed theta minus 3 sine squared theta cos theta, and then on this side we're gonna have plus 3 sine theta cos squared theta minus sine cubed theta I. Okay, so that's the real part, and that's the imaginary part. Okay, so once we have that, then we can look if we use de Moivre's theorem to do this. Okay, so I'm going to do this in a different color. So sorry, that's a big block of red, but hopefully that all made sense. You can just pause it and go back if anything doesn't make sense. It's just long and arduous, but it's just about getting the right answer. Try not to make any mistakes, and then the question should be fine. If you start this and you make a mistake, it's fine, because at least the examiner knows you're on the right track. So then your next step is going to be that cos theta plus I sine theta cubed is going to be equal to cos 3 theta plus I sine 3 theta. And we know that because that's de Moivre's theorem basically. Okay, so now we're going to look at kind of identities. Okay, so I sine 3 theta, okay, is the same as this one here, because we did the same thing. So cos theta plus I sine theta cubed is equal to this by de Moivre's theorem, and also cos theta plus I sine theta cubed is equal to this just by algebra, by making it out. And we know the I bits have to be equal to the I bits, so we can say that sine 3 theta is equal to what we have here. Okay, so I'm going to say that in green. Sine 3 theta is equal to 3 sine theta cos squared theta minus sine cubed theta. Okay? Okay, so the next step, we need to get rid of this cos, because in our answer here at the start, the proof, there's no cos. So we're going to get rid of that cos theta. Okay, so this is another trigonometric identity. I'm going to scribble this here, and then I'm going to get rid of it. So cos squared theta plus sine squared theta is equal to 1, and this is quite important. Okay, so that means we can say that cos squared theta is equal to 1 minus sine squared theta, and this, either this one or this one, will be in your logbooks, and it becomes quite important. You might use it quite a lot, so bear this in mind. So remember, this is what we're going to use. Cos squared theta is equal to 1 minus sine squared theta. So I'm just going to get rid of this. Okay, got rid of it. So now we can write sine 3 theta is equal to 3 sine theta by 1 minus sine squared theta minus sine cubed theta. That's going to give us that 3 sine theta minus 3 sine cubed theta minus sine cubed theta, and all of that together is finally going to give us our answer is equal to 3 sine theta minus 4 sine cubed theta. And there we go. Okay, so sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta. We'll check if that's the same thing, and it's the same thing they have up here, so we've proved that. Okay, so I know that's quite long, quite difficult, but if you take the steps anyway, you'll get most of the marks for the method. If it doesn't work out, don't be too worried about it. It's kind of one of the quite difficult ones, but hopefully this video helped anyway, making it clear. I know it could be quite confusing, the big wall of red text, but watch over it a few times, and if you get it, it's good, because it could come up in the exam.